Alright everyone, today we're going to take a look at this inequality here and how to solve it. It is a quadratic inequality, meaning it has an x squared in it. Usually when you have quadratics, the thing you want to do is factor. So if we move our 5 to the left side, so subtracting 5 on both sides, I'm now going to have 3x squared plus 16 is less, minus 5 is less than or equal to 0. Now, I'm going to go off in the corner and just, set it equal to 0 so that I can find solutions. Then what we're going to do is actually test where we are less than or equal to whatever in comparison to 0. Because at this point, it's not as easy to tell which way my inequality is going to go. If you were to graph it on a number line, it either will be in the middle region or it may be going outward like this. So we're going to test that later, but we need to know where our boundaries are. And we may write this in interval notation, or we may write this in just by putting something as less than x, which is less than something else. But, that's just kind of that's just a rough idea of what we're going to do here. But I'll show you it in sequence. So first, we need to just factor this. So I'm going to set it equal to 0 so it makes sense why I'm factoring. There's supposed to be an x there. There we go. Fix that over here. 16x minus 5. I'm going to move that. I don't like how it's just off. Put my x back in there. All right. Okay. And, I've done this problem before with a student, and we were just really confused on what to do. We couldn't factor this traditionally, like factoring by grouping or slide divide, whatever the way you factor it. We tried to maybe break this up into some numbers that would be able to be grouped on this side and this side. For example, maybe like 3x plus 10x, and then surrounding the other ones. Did it a couple times and just realized, okay, this is not factorable in the traditional way. So we tried doing the quadratic formula. So quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a great song that helps you memorize the quadratic formula that I would recommend. I might link it in the description of this video. So if this is a, this coefficient is b, this coefficient is c. Remember that c is negative. We're going to pop this into the quadratic equation and see what happens. So, negative 16 plus or minus the square root of 16 squared minus 4 times 3 times negative 5 over 2a, which is just 6. Just going to save my breath. Or maybe I'll keep it as this. It's actually going to come in handy later. All right, 2a. Okay, so going to have to rewrite this again. 16 squared is 256. I didn't do that in my head. I have a calculator handy. You could just plug that in the calculator real quick. Here we have we have a product of 3 numbers here. And 2 of the numbers are negative, so I know the result's going to end up being positive. This negative 4 is going to multiply by the negative 5. We're going to get something positive. I think it's easier to think of it like, okay, what is 3 times 5? That's 15. What is 15 times 4? That is 60. And that's just because I know that 15 plus 15 is 30. And then 2 more is 60, right? They're kind of like multiples of 15. 4 15-second intervals fit in a minute, so that's how I know that that's true, but you could double check that in your calculator. And then you got, I'm going to leave the 2 times 3 in the bottom. You could make it a 6, but I'm just leaving it that way because I might be able to cancel this later, but I can't do that right now. Now, 256 plus 60 is 316. I'm going to scroll down a little bit here. 16 plus or minus, and now we have 316 here. All right, and this is over 2 times 3. Now the fun part happens. We need to, it would be really nice if we could cancel this, but because of the addition here, there should be something in front of here that we could also cancel with this 2, but there's just a 1 out there. So we might be able to divide this number, as in maybe in the corner we could break it up into 2 things that multiply by each other under the square root, and then we can actually pull one of them out. So I would probably check, is 316 divisible by 16? It is not. Is 316 divisible by 4? It is. And we've got a 79. Just out of curiosity, I'm just kind of plugging in. Oh, that's not even a square root. What am I doing? Well, you know, I might as well check if it's divisible by anything else and see if it's divisible by... What am I doing? I don't know how to use this thing. Sorry. Checking if it's divisible by anything else. Like if it was divisible by 7, maybe it'd be divisible by 7 squared. So I'm just making sure. I know it doesn't seem to make sense. Let's be real, it's probably going to be 4, but I just want to, like, I don't know. Sometimes I just check. Yeah, I'm pretty sure it's just going to be 4. I think we're good. All right. Goodbye, calculator. All right. So now we have negative 16 plus or minus, and actually maybe I'll do it over here just to kind of demonstrate what am I doing. So the square root of 316, you can think of it as the square root of, what did I just say, 4 times 79. That's kind of small, sorry guys. And you could then break it up into square root of 4 times square root of 79, or you can think of it as taking the 4 out and making it a 2. But either way, you're going to end up with 2 times the square root of 79. So that's my little aside. I guess I could, where did my pointer go? I could put it in a little cloud. All right. So we have that. So now I'm going to make it negative 16 plus or minus 2 times the square root of 79 over 2 times 3. At this point, it's tempting to just do this, just like I was saying before. But you actually have to cancel it like this. If that is confusing to you, remember, I can rewrite this as a negative 16. Wait, what am I doing? Oh yeah, I could reverse distribute a 2 out of here. And that's actually how we cancel. So you can cancel it this way. But if you want to see why, so that you don't forget, because then if you start canceling this way, you may in the future have a tendency to just cancel these, and that would be illegal, and you would just totally get the wrong answer. So if you think about reverse distributing a 2, thinking of it like this, okay, right? That's the same thing. Now imagine redistributing it. You get negative 16 there, and you'd have a 2 times the square root of 79. So that's a valid thing that I can do. And now it makes more sense that I can cancel the 2's. So now that I've canceled the 2's, my solutions are going to be negative 8 plus or minus the square root of 79 over 3. And I can kind of just, you know, separate those as negative 8 plus the square root of 79 over 3. And we also have negative 8 minus the square root of 79 over 3. So x equals these 2 things. And, you know, this isn't the solution to our actual problem here because we had an inequality. But these are going to be useful when I draw my number line and just figure out where my values are supposed to be. Essentially what we have is we have some parabola, and it's crossing through, I guess it's probably more like this, it's crossing through the x-axis at these 2 points because those are the x-intercepts. But I'm trying to figure out if my function is going to be in here or if it's going to be out here. And I can best check that just by figuring out, is x supposed to be greater than here? Or is x supposed to be within here? And I guess in reality, my solution would, maybe it would look a bit more like this. I don't quite know what it looks like graphically, to be completely honest with you. I just know how to get the right answer. Anyway, sorry. I hate admitting that as a tutor. I don't often admit that, but in this case, it's just kind of true. All right. So the next thing we need to do is test which way are we going? Are we going out like that? The arrow's facing outward, or are we doing the arrows facing inward? I'm going to find the decimal equivalent to these because it's going to be a lot more annoying to test value. Like, when you look at this, you don't know what number that is. If our solutions were like -5 and +4, I could probably pick some numbers. Like, I could pick a -10, I could pick a 0, and then I could pick like a 5 for testing my values, and you'll see what I mean in a bit. But I don't even know what this even is, so we've got to, let's put it in decimal equivalents so that I can at least figure out, you know, what are they approximately. So, grab our calculator. I don't know how to use this thing. We're going to try. -8. How do I just make a negative? It's just, it says, oh, there it is, there it is. -8. What? Okay, 8 negative. I guess that's what they want me to do. 8 negative plus 79 square rooted. There we go. -8 plus the square root of 79. So we got to do backwards. Divided by 3. Oh, wait. Oh. Order of operations here. I don't know how this calculator works, so I don't know if they did it right. Okay. I'm going to try that again. -8 plus the square root, or 79 square rooted. So then I do that. Why did it, what? And then I have to divide by 3. Okay. All right, we're gonna roll with it. That is what I got the other time that I did it. So we have, oh, I can't actually see that when I write it down. Okay, 0.296. We're gonna just do that. Come on, why is this not working? 0.296. Okay, I'm gonna do it again. This calculator is pretty painful. I think that's how to use it. So now we do 8 negative minus 79 square rooted. Gonna hit the equals button there, and then we're going to divide by 3. Okay, -5.629. -5.629. So those are my solutions. I probably should have written them in reverse. We usually like the negative one to go first, but that's okay. So now let's draw a number line. Boom. I have -5.629 over here. I have a 0, probably, I just usually like to mark my 0 so I know that I'm on a number line. Then I have like a 0.296 over here. Now what I'm going to do is I'm going to insert 3 test values into these intervals here, and I'm going to check for any number in between here. Is this true? Is this equation true for those numbers? It might actually help me to rewrite what I have. Okay. So I'm going to kind of put our golden equation up in yellow. It's kind of, I don't know if I can see that very well. So we've got 3x squared plus 16x minus 5 greater than or equal to 0. Nope. It's less than or equal to 0. I believe that's what we're doing. Okay. All right. And now I simply have to insert my test values into that equation. All right. So what's a good test value for this? Now, I guess -6 is everyone's like choice that they would immediately go to, but I'm going to do -10 just because 10 is an easy number, because then I can do 3 times 10 squared, which is 100. So I'm just do 3 times 100 plus 160, because 16 times 10, because we're supposing that x equals -10 here. I might as well write that. We're going to test for x equals -10. And then we got to do -5, and we have to say, is that less than or equal to 0? And it's definitely not. You've got like 300 here, 460 minus 5. So I guess that's 455. And this is approximate. I may not even be right or not, but it doesn't matter. It's clearly not a negative number. So we're going to say this does not work. That's not in our domain. I'm going to check this side. All right, so we're going to test for And I think the most obvious choice is we're going to test for x equals 1. All right, so we've got 3 times 1 squared, which is just 3. We have 3 times 1 plus 16 minus 5. Things are looking up, but still you've got 19 minus 5, which is 14. I don't know if I'm doing this math right. I'm not actually that great with standard or like really arithmetic, but anyway, I'm pretty sure it comes out to something that is definitely a positive number. It's definitely not less than 0. So this is not in our domain. Now we're going to test a number in here. I could test 0. 0 sounds really easy, right? So if we do test 0, so test for x equals 0, we really just get -5, right? Because, 0 squared is 0 times 3 is 0. Anything with the x's just kind of goes away. You're really just testing your constant value. And -5 is less than or equal to 0. I did this problem once and I said, oh my god, -5 is not less than or equal to 0. We're all doomed. But I was thinking of the magnitude. Like, 5 is more worth than 0. But because this is -5, it is less than 0. It's just the 5 kind of distracts you. But you're saying that -5 is more negative than 0, which it is. I wanted to fix that. All right, so we can say that this value actually works. So this is in our domain. So now we're remembering that these actual values here were -8 minus 79 over 3. This was actually -8 plus 79 over 3. That is super small for some of you reading. You don't really have to read that. I'm just making note of that to myself for the next page. So, in short, we know that x is in between these two numbers. If I can see how this highlighter tool works, I've never used it before. Oh, there we go. Okay, so we know that x is somewhere in here. We also know that it can equal these numbers as well. So when I do my interval notation, I have to remember that it can be equal to. So sometimes I like to draw those brackets there. If it was just less than, without the equal to, I might draw parentheses here just to indicate that I'm skimming or I'm just barely touching that value. I'm not actually getting to it. That's kind of how I like to think of it. So I'm going to put these in here just to kind of notify to myself that that's what we're doing. I'm going to go to the next page so I can write our answers out. So our answer to this question is, we're really asking what is the domain of this equation, or yeah, what satisfies this equation. So we're going to say, we could say that x is in between these values, so we could write it out this way. X has to be greater than or equal to that, but less than or equal to this. And you could, I'm just kind of rewriting what it is, on if we're looking at our decimals, x has to be greater than the negative decimal value we have here and the positive one here. It's in between, but it's probably better to write it in the actual, the exact form. That's how I was always taught to do it, but you may not have been. It depends on what class you're in, really, but this is how I like to do it. I guess I could write the small one. Not the small one, sorry. The decimal equivalents, if anyone's interested in that. I think this was it. 5.629. X has to be in between these values. 0.296, I think. All right. And so this would be the answer in just like, I guess, it might be set builder notation. X is a member of this. I don't quite remember set builder notation, but it depends on what your test or your homework is asking you to do. It might ask you to put it this way. It may ask you to do it in interval notation. If we're going to write this answer in interval notation, we are going to say that from -8 minus the square root of 79 over 3, we're going all the way to -8 plus 79 over the square root of 3. If for any reason we did this test and we found the opposite to be true, suppose that these values were the ones that worked out and this value didn't, we would have to say that x goes from negative infinity all the way up to this value. And then we'd have to say it also goes from this value up to positive infinity. And we'd have to put a big old union sign in the middle, meaning skip this portion. That didn't happen. So for this particular problem, this is our answer. If you are going to write it in decimal, it would, sorry, that I didn't know I could do that. It would be the same thing. We would have negative 5.629, and then you'd have 0.296. It's kind of weird that these numbers happen to be each other scrambled. That usually doesn't happen. Anyway, that is the answer. Thanks everyone for watching. Sorry if this was messy. I was doing this as a last-minute video for someone who was curious about this question. Throughout the weekend, I may upload more, depending on if I have the time, or next week, I may go through ones that you can solve via factoring instead of the quadratic equation. I may do ones where you have to put the union in the middle and the solutions go left and right on the number line towards infinity. That way you just have a more well-rounded understanding of how to do this. All right, thanks for watching. Have a good weekend.